Hello everyone, welcome back to ChemONotes. Welcome back to the rearrangement series, part 4. Today we will be studying about Curtius rearrangement reaction, which is the most important reaction which is often asked in SET, NET, GATE, JEE and CET exam. What you are going to learn in this video is step-by-step mechanism, key notes and some shortcut tips to remember. So grab your books and stay tuned with ChemONotes. Apart from this rearrangement, we are going to see few more rearrangement like Hoffman rearrangement and Lawson's rearrangement, which are similar to Curtis's rearrangement in the upcoming videos. So stay tuned and please subscribe, hit the bell icon so that you can get the notification and like the channel. So let's begin. So the Curtius rearrangement is basically a carboxylic acid derivative. Usually we take acyl halide. Okay, it is thermally decomposed to give an isocyanate. So here isocyanate is an intermediate which further reacts with different reaction medium and they can form into amines, euthranes or urea derivatives. Okay, so let us understand how the Curtius rearrangement takes place. So this is your acyl halide, that is R C double bond O N or N3 we can write it in short form. Okay, let me write it down so that you can have in the exams. Most of the time they will not give you N double bond N double bond N, but they can directly write it like this: R C double bond O N3. Okay, N3 is your azide. So here basically you will find nitrogen is N double bond N double bond N. So this group you will find that it is minus, okay, this is plus and this is again minus. Okay students, so the first thing is you are going to heat this reaction and you will find that it gets converted into your isocyanate. What happens is it gets converted into isocyanate. So we are going to see the mechanism, but you are going to heat this acyl halide and you are going to heat it, and what happens is N2 group is eliminated. Okay, N2 group is eliminated, and at the time of elimination there is rearrangement taking place. As you can see here, the R is connected with carbon, that is carbonyl group, but in the isocyanate R is connected to nitrogen. That means there is a rearrangement taking place between these two steps. Okay, rearrangement also takes place in the first step itself, and you get a isocyanate. So this isocyanate is a intermediate which can be further converted either into amines, euthranes or urea depending on what is the reaction medium. So let us see. As you can see, isocyanate, if you react with alcohol, that is ROH, it gets converted into carbamide. Okay, that is RNH double bond O OR. So this is your carbamide. Then next you will find when the isocyanate reacts with water, it simply converts into amines. That is, your carbon dioxide will be removed, and this is R NH2 is going to form. Okay, so there is elimination of carbon dioxide gas in this, and you will find that there is a formation of amine group. So we can even write it here minus CO2. Then the last one is, you can see isocyanate has been converted into urea derivative using what? Using amines. So if you react with amine, isocyanate gets converted into urea derivative. So that is RNH C double bond O NHR. So it is a urea derivative. Okay. So this way in exam they can ask you From acyl hazide, either they can ask you any of this one product. Okay, so let us see the mechanism. So first step is to prepare acyl hazide, and acyl hazides can be prepared by various ways that we will see in the further slides. But let us first find out preparation of acyl hazide using acyl halide. Okay, you can take either acyl chloride, acyl bromide. So acyl halide is converted into acyl azide using the reagent sodium azide. Okay, what you can do is you're going to prepare a acyl hazide using acyl chloride. So let us see the formula first. That is RC double bond OCl. So as you can see here, it is simply your RC double bond OCl. So it is acyl chloride. Instead of Cl, you can have bromide. Okay. Instead of this Cl, you can have Br. Any halide you can have. That is reacted with your either sodium azide or potassium azide. So here what will happen, this is in this fashion, NaN3, which we can show that Na plus and this N3 is there. Okay, now this N3 will have N minus, this will be plus and this is minus. Okay, so this is going to be there with the sodium, or potassium also we can have. So it can, you can either use sodium or potassium. So here, or potassium azide also we can use. Okay, so what happens is the sodium, as I have shown you, that sodium is eliminated and this azide group gets attached with the acyl chloride and chlorine will be removed. So basically you will find that here this minus sign is going to attack on carbonyl. Okay, it will come back and it will eliminate the chloride ion. So this sodium Na plus and Cl minus, so it will be formation of NaCl, removal of NaCl, and here you will find that there is formation of R. Okay, so as I have shown here, that basically you will get three things in one go. I had shown you, but you can show it in this fashion also. Okay, so what I'll do is I'll remove from your Cl. So here you will find that after oxygen minus sign, the electrons get shifted, the chloride ion will be eliminated, and you are going to get a acyl hazide, that is RC double bond O N3. Directly also you can write N3. Okay, if you are going to write it as N double bond N double bond N, then you have to show the charges on nitrogen, as nitrogen, the center nitrogen has formed 4 bonds. So obviously the center nitrogen will carry positive charge. Okay, and the terminal nitrogen, you will find there are only 2 bonds, so there is a negative charge, whereas the nitrogen here has formed 3 bonds, so it will not carry any charge on it. 1 2 3. So this nitrogen which is connected with carbonyl group will not carry any charge, whereas the center nitrogen carries positive and the terminal nitrogen will carry negative charge. Okay, similarly here you can show. So this way acyl azide we have prepared. Now next is, we will see how acyl azide has been converted into your, okay, let us see the next thing, how to prepare isocyanate. Then the second step is formation of isocyanate, in which acyl hazide, that is R C double bond O N N3. So N3 we can write it in this way, that is this will carry, center nitrogen will carry positive charge, terminal nitrogen will carry negative charge. Now let me show the resonating structure of acyl azide, that is R C double bond O. Here you will find that there is shifting of electrons. Okay, if the pi bond shift here, then this electron will shift on nitrogen. So The nitrogen which is connected with the carbonyl group will carry minus charge. N center will have again the plus charge, and this is a resonating structure. Now in this resonating structure, what happens is there is elimination of nitrogen molecule. That is, this bond will break. I'll show it with different color. This bond is going to break and it will try to neutralize the positive charge. So there is elimination of N2 molecule, and you will find that you are going to get a nitrene. This compound which is formed in between is called as nitrene. Okay, Nitrene, nitrene. Why? The nitrogens will be having lone pairs. Okay, and this is an intermediate. Now this nitrene, what happens is, the next step, basically the proper Curtius rearrangement takes place and you get a isocyanate. There is a rearrangement going to take place. How it goes on? That is, the electrons will shift here. Okay, they are going to shift here and it will push this R group, that is rearrangement, to nitrogen. So we are going to get a isocyanate this way. That is R. You can find here this R has shifted to nitrogen now. So nitrogen, then you here is a double bond formation with nitrogen and carbon. So there is a double bond formation, C double bond O. So this is known as isocyanate. And as you know, further the isocyanate can be converted into carbamate or amine or urea derivative. Okay, students. So this way, these are the applications of basically the Curtius rearrangement reaction. I think this is clear. Now let us go to the more ways to prepare azides, acyl azides. So as you can see on the screen, we have taken few reagent starting materials such as, let me write them. What is the first one? The first one is as carboxylic acid. Okay, it is a acid, carboxylic acid. So first is carboxylic acid. Then you can find the second one is acyl chloride or acyl halide. Okay, we can have acyl halide or acyl chloride, and you react with sodium azide. Here we are going to react with two things, that is PCl3 and sodium azide. So PCl3 first it will convert it into what? The acid will first get converted into R, C double bond O, Cl. That is the first step using PCl3, that is phosphorus trichloride, and then it will then react with your sodium azide to form isocyanate. Then isocyanate will get converted into your the amines, depending on what is the starting reagent used. Similarly, here you can find the third one is ester, then fourth one is acetic anhydride, and the fifth one again is your carboxylic acid. So any one of this, and the reagents you can find here written, that is we can use sodium azide, we can use hydrazine and nitric acid, then we can again use sodium azide. Okay, so these are the starting materials which we can use to prepare acyl azide. Okay students, after acyl azide, this is your acyl azide, and as we know that acyl azide can be easily converted into different groups depending on what are the starting materials. So acyl azide, you're going to convert it into isocyanate, and then isocyanate will get converted into the products. So let us see few practice questions based on CET-NET exam papers. So as you can see, the first one, there is a benzene ring, CH2, C double bond O, Cl. So it is acyl chloride which is reacting with sodium azide. So once you see acyl chloride and sodium azide, you should remember that it can undergo Curtius rearrangement reaction. So acyl azide is going to convert into, you can see here, Cl has been converted into what? N3. Okay, your acyl azide. So acyl azide, then after heating you will find that it gets converted into directly what? Amine group. Okay, so basically it will undergo the Curtius rearrangement. But if you want to know the trick is simple, that what is C double bond O, N3 gets converted into NH2 group. Okay, C double bond O and NH3 gets converted into NH2 group. This is the trick. Directly you can write in the exam. No need of doing the mechanism. So C double bond O, let me highlight this. Let me highlight it using, yeah, C double bond O, NH3, we can directly convert it into, okay, this is the trick, students. We can directly convert it into NH2 group, amine. Similarly, you can see the second question. Second question, there is a benzoic acid, SOCl2 and NaN3, that is sodium azide. It will get, first step is it will get converted into acyl chloride. Acyl chloride will get converted into acyl hazide. Now once you can see acyl hazide, it will get converted into NH2 group. Okay, so this is a very simple trick you can remember, and you can solve the paper. Now one more thing about Curtius rearrangement is, there is whatever is the configuration given in the exam, it remains the same, so it retains the configuration. Okay, Curtius rearrangement, you will find that there is retention of the configuration. So if the starting material is R, okay, R configuration, you will get R configuration. If it is S, you will get S. So you have to find out the basically your chiral carbon. So it will always you will find that the chiral carbon will retain its, okay, chiral carbon will retain its configuration. Okay, students, so this also you have to remember, you should keep in mind. So let us see the third one. So if in the third, if you see the example, there is acid, carboxylic acid, then the azides. So obviously the carboxylic acid first will get converted into acyl halide. So you will require one more thing here, SOCl2 also, and the second is NaN3. So azide is formed, then azide gets converted into amines. So I'll just highlight this. That is, this is your acyl hazide, which gets converted into amine. Now the next one you can see here. So similar questions I have shown here. The acid, carboxylic acid, using same SOCl2 and NaN3. It has been first converted into acyl hazide. Okay, then that acyl hazide has been converted into your amine group, NH2. So very simple Curtius rearrangement reaction. There are few more which were asked in the CSIR-NET exam, that you can see here: CH3, CH2, CH2, C double bond O, Br. So it is acyl bromide. Then sodium azide is on the arrow. So you will find that the acyl bromide has been converted into acyl azide. Okay, and then it gets simply converts into your amine using Curtius rearrangement reaction. The sixth one, if you can see, even the molecule is little bit complex, but you don't have to worry, because you have to only concentrate on the reagents which are on the arrow and whether there is acid. So here you can see that there is acid group. Here there was acyl halide, okay, which on the arrow it is SOCl2 and sodium azide. So it is going to undergo your Curtius rearrangement reaction. CO carboxylic group has been converted into CON3 acyl azide, and that will get converted into amine group. Okay, so now let us find the seventh one. Seventh is, you have a triangular, that is, we can call it cyclic cyclopropane. Okay, and it is already acyl azide, so it has to be converted into, after heating it will simply convert into amide group. So directly you can show it. Okay, directly, because options in net and set exams, options are given, you have to just tick the correct one. Now same way, eight question, already they have given us acyl hazide. The product will be a benzene ring. Okay, here it will be directly, as I've told you the trick, NH2, so it is a diamine. Next one, even though the reactions seem to be complicated, you can just go through the reagents which are written on the arrow. Okay, it is simply, what is going to happen is, first step will be C double bond O Cl. Okay, and next step will be formation of acyl hazide, and directly you can write the product. The product will be, yes student, now you know what it is, what is the product. The Cl will get converted into, first of all, N3, and then it will get converted into amine. So directly I am writing the product. Okay, this should be the product, and there is always retention of the configuration, so whatever configuration is given in the answer you can find out and write the correct answer. Okay, with same configuration whichever is given in the starting material. So this was the thing, got it? Yes. Now the last one, it is again very simple, benzene ring with 1 2 3 4, and here will be NH2. So just count the number of carbon. This is your first carbon, second, third and fourth carbon. This whole will get converted into, as we have seen that acyl hazide gets converted into amine group. So third carbon will carry NH2 group. So let us see 1 2, third carbon has NH2 group. Okay, so this way you have to solve the questions on Curtius rearrangement reactions. Now stay tuned with the ChemONotes, and thank you for watching. We are into the rearrangement series. Okay, so today was part 4th. We already completed part 1, part 2 and part 3. So you can go and visit the playlist of at ChemONotes and see other videos of chemical sciences. So stay tuned with ChemONotes, and if you like the description, hit the bell button and like the channel. Please subscribe if you are not subscribed. Share it with your friends. Thank you for watching. Bye till then.